All right, so for today's lesson, this is the final lesson of the topic, and then we're going to slow down on, let's see, Friday for you guys. We will do a topic review all day, and then on Tuesday of next week, you guys are going to take the quiz over it. So this is modeling behavior. I'm going to go a little quicker than I usually do in person because you guys have the ability to rewind and pause whenever you need time. And also, I'm not going to be asking questions and waiting for you guys to answer, so this isn't going to take too long. First thing we're going to do, well, first, turn to page 159 in your workbook. And now we're going to do a warm-up. And this is something that you guys learned when you were in Math 1 last year. And this table shows a bunch of points. And if you were to plot them, it's going to make a scatter plot. And we learned last year how to find a line of best fit. And sometimes we had to draw it in ourselves and find the equation, but we also learned how to do it in Desmos. So what you need to do, I've already done it for you, but if you go to Desmos, you're able to click on the plus sign that's at the very top on the left side. So right under where it says Untitled Graph, there's that plus sign. You click on that and then you can insert a table. So you see it right there. I've already done it for you. So here's the table from the warm-up. And if I go to plot it, it's going to look like that. So that's definitely a scatter plot. We want to figure out what line would be the best fit. So I'll use my little pen here. Could it be this line? Would that fit the points well? Could it maybe be this line? We don't really know, right? So what we can do is we can use this formula. Sorry, I'm trying to multitask and erase what I just saw. Oh, it's going to make me do that. It's going to take forever. Desmos will calculate the line of best fit for you. So if you see down here, y1 and then the little squiggly, which is the tilde, and then mx1 plus b. If you type that into Desmos, it is going to give you the line of best fit along with the equation of the line of best fit. There we go. So that line right there is the best depiction of those points on the scatter plot. And then if you look over here, where'd my little colors go? There they are. It gives you the slope and the y-intercept of that line. So if I wanted to write the equation of this line, it would be y equals, my pen's not working, so I have to use my finger here. Y equals your slope, which in this case is 0.87, times x plus your y-intercept, which in this case is 33.56. So this would be the equation of your line. This formula needs to go into your workbook or into your notes somewhere, and you need to label it linear regression. Looks like I've never written before. This is really sloppy. So that is the formula that you will use in Desmos anytime you need to find the line of best fit. All right. If you guys needed help on that, you can just pause. Let me go back to my cursor. So today we're going to learn how to use a quadratic function to model data, interpret characteristics of quadratic function, and then make predictions based on a graph. So we're really doing two main problems here. The first problem is about pop in a freezer, and the second problem is about a crime scene, which is my favorite. So to get started, we're going to start with this soda scenario, even though normal people call it pop. A 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can measured at different temperatures. So you'll notice that as the temperature goes down, well, what's happening to the output? So as the input decreases, so as the temperature decreases, what is happening to the volume? A lot of students immediately say it's shrinking. So if you look at the first four numbers in your output, it does look like it's decreasing. But then notice what happens next. It looks to be increasing again. So describe the data distribution. As the temperature decreases, the volume decreases and then increases. So get that into your workbook. If you need to pause, go ahead and pause. So what have we worked with this year that goes down and then up, or up and then down? This will most likely form a quadratic. So we're not really talking about linear models anymore. This is more of a quadratic model. So question 2 says create a scatter plot of the data. Sketch the plot of points on the coordinate plane shown. So what I want you guys to do, I'll use my pen here. Take these points and I want you to put them on the graph right here. So pause and take a couple minutes to plot all, I think it's 8, 1, 2, 3, 4, 5, 6, 7, 8 points and get them onto the graph. All right. So if you plotted those, it should look like this. So you should, depending on how you scaled, this obviously is going to make it look really nice to us because Desmos knows how to adjust the scales. But you should notice that it kind of makes a U shape. So our prediction that it's probably a quadratic model, a quadratic relationship, is pretty accurate. So now we can't use that linear regression model to draw in a line of best fit because there is no line that is going to fit this graph because it's not linear. So notice what you have over here now is a quadratic. So again, this is really important. Write that into your workbook or into your notes. And this is your quadratic regression. I left my good pen at school and I'm really upset about that. This is really ugly. Okay. So what does it give us when we write that equation into Desmos? It gives us our A value, our B value, and our C value when we're trying to write this quadratic equation. So if I try to do it, I'm going to get y equals ax squared. Well, A is this crazy number, 0, 0, 0, 9, plus your b, or in this case, since b is negative, negative 0.07x, plus your c. And my c value here is 356. I'm running out of room. 4. So that's how you'd write the equation of a parabola when you know it's a quadratic regression. So now we're going to explore that a little further. So let's continue to analyze the data and make some predictions about the volume of soda at different temperatures. So question 1 on activity, I know it says 3.1 for you guys in your book. I know it says 4.1. We're using the algebra textbook for this. Use technology to calculate the regression equation that best models the data in the previous activity. So we kind of already did that in purple on the last screen there. Sketch the graph of the regression equation on the coordinate plane on which you created your scatter plot. So go ahead and connect your points on your scatter plot in your workbook and create that parabola there. So you're just drawing in what's red that you see on my screen. All right. And we're going to ignore this little piece right here. Question 2 says state the domain and range of your function. How do they compare to the domain and range of this problem situation? So what we're doing first is we're going to just look at the quadratic itself. We're looking at the red part, and we're going to state the domain and range of it, and then we'll talk about the domain and range of the story problem. So for the function, which is just the graph itself, the domain, if you remember, is always your x value. So I like to look at that like it's talking about the width of the graph. And we all know that parabolas go on forever, and they get wider and wider and wider and wider. So the domain of this is all real numbers. Next, we're going to talk about the range. Range is all the y values that make the graph. So I like to think of it as the height of the graph. So we definitely start, and then we go up forever. So where is our starting point? It's our lowest point. So if you take a look at the table, looks like our lowest point is 354.88. So the range is all y values greater than or equal to that value. So 354.88. That's the lowest. It's the range is there and everything above. Now we're going to talk about the domain and range of the story problem. The domain is all of your x values. So all of your x values that make up the graph would be right here. So that means my domain is everything greater than or equal to 14, but less than or equal to 68. So it's everything in between those two, including those two. And then the range, let me change my color, would be all of your outputs. So we need to see where the lowest and the highest are. So this one takes a little bit more time. We've already discovered that the lowest is the 354.88, and which one is the highest? So 355 looks like that's going to be your highest. So our range is going to be everything in between those two values. So y is everything greater than or equal to 354.88, and it's less than or equal to 355.54. All right, question 3 says, use the regression equation to answer each question. Well, we can kind of cheat a little bit and just go to the graph. So determine the y-intercept and interpret its meaning in terms of the problem situation. So this one is not as hard as most students have been making it to be. So all we're going to do is just look at the y-intercept. I'm going to click on it, and it's 356.353. So let's interpret what the y-intercept means. What does that mean in terms of the story problem? Well, your inputs are temperature and your outputs are volume. So what that means is it going to let me write? No, it's not. When the temperature is 0, sorry guys, this looks terrible, is 0 degrees, the volume is the 356.353. So if you were to keep decreasing the temperature of the freezer, the volume would increase to 356.353. Okay, 3b is asking, determine the x-intercepts and interpret the meaning of those. So let's go back to Desmos. And let's look at the y-intercepts here. So it looks like, if I were to zoom out, we aren't even close to where the x-axis is. And sorry, I said y-intercepts. I think I said y-intercepts. I mean x-intercepts. We don't have any x-intercepts. So the whole graph, the problem, starts way up higher than the x-axis. So what does that mean? Well, let's go back to the presentation here. If there are no x-intercepts, and I know that y represents the temperature or the volume, on your x-axis, y would be 0. So what that means is your volume can never be 0 because there aren't any x-intercepts. We're going to skip question 4. Now we're moving on to the second problem, and then we're done after this. All right, so this one I think is the coolest one out of everything, and I think it's the coolest problem out of anything we've done all year. So this is activity 4.2 for you. And it says, Arlen City Police Department is offering special classes for interested high school students this summer. Elsa decides to enroll in an introductory forensic science class. On the first day, Dr. Suarez tells Elsa's class that crime scenes often involve speeding vehicles, which leave skid marks on the road as evidence. Taking into account the road surface, weather conditions, the percent grade of the road, and vehicle type, they use this function, and it determines the length in feet of skid marks left by a vehicle based on its speed, s, in miles per hour. So my independent variable is the speed, and my dependent variable would be how long the skid marks are in feet. So the speed can be anything it wants, and then it's going to decide how long the skid marks are. So question 1 says, complete the table based on f of s. Label the column titles with the independent and dependent quantities and their units. So like we just discussed, this would be speed. In miles, you can write under that, but I obviously don't have room. And then your output would be the skid marks. I'm just going to write skid. So we could take a while, and I could have you guys plug in 20 all the way to 110 to figure out what the corresponding y values are, but I'm just going to give them to you. So when a car is going 25 miles per hour, the skid marks will be, writing, 18.65. When the car is going 30 miles per hour, let me erase that real quick, it's bothering me. We've got 32.8 feet of skid marks, and then so on, so on, so on, so on, so on, so on, and so on. So pause this and get that written into your table. All right. So question 2 says, according to the table, what are the domain and range for the problem situation? So it's not talking about the actual graph. It's going to just talk about what do you see in the table. So remember, domain is your x values. So all of the inputs that are involved in this graph, or in this table. So it looks like 25 is my lowest speed and 110 is my highest speed. So the domain would be everything in between 25 and 110, including those. And then the range is your output. So take a look at the skid mark length. Looks like 18.65 was my shortest and 490.4 was my longest, which is really long. And so that means my range is going to be everything in between those two numbers, including those numbers. Okay, question 3 says, graph the table values and sketch the graph of f of s on the grid shown. Label the axes. So you could go ahead and make plot all of these as accurately as you can, or you can just copy what I have. So here's what the graph would look like. Try to be as accurate as possible. What I might do, I might graph like the first one, maybe a middle number, and then one of the last ones, and then connect my points. So pause here, put that into your workbook. So question 4, it says, during another class period, Dr. Suarez takes Elsa's class to a mock crime scene to collect evidence. One piece of evidence is a skid mark that is 300 feet long. So part A, use the graph to estimate the speed of the vehicle that created this skid mark, and then explain your process. So go ahead and pause, try to figure out, you could do it algebraically or you could do it with the graph. How fast do you think the vehicle was going if the skid mark was 300 feet? All right, a couple things you could do. You could go ahead and look at your own graph that you put into your workbook. And I'm going to go to 300, and then I'm going to go all the way over to my graph, and then I'm going to go down from there, which obviously this pin is not going to work for me. So it looks like I'm slightly before 90. I don't really like how inaccurate that is, so I'm going to go to Desmos, and I'm going to plug in. So you would have already had to do this, plug in the table, and then you find your quadratic regression, then you'd get these 3 numbers to plug in. So now what I can do is if I know we're going 300, I can just slide until I get to 300, or we're not going to 300. We're trying to find a skid mark of 300. So I can scroll like this, or I could go here and say, when is y 300? And now all I have to do is find the intersection. So it's approximately 85 miles per hour. So good guess if you got that right. All right. So the next video is going to talk about the assignment that you need to do today, because I need to show you how to do it because it can be very, very confusing.